Hi everyone. This autonomous connected vehicle lecture series. This video we discuss about the cruise control using LabVIEW. Normally the cruise control is the maintain the desired speed. So in this video we discuss about the basic theory about the cruise control. The next we have to develop in the LabVIEW platform. Those things we discuss in the this lecture series. Actually, this is we identify the how to get driving problem. So, what is the how to control theory? How to maintain about the constant speed? Then we are developing the one LabVIEW model. We check it the LabVIEW model how to vary the speed and maintain about the constant speed and identify the speed error. Then from that LabVIEW experiment, we have to identify the interpretation from the slow, stable, and aggressive response. The simple block diagram about the cruise control. We given the input and control logic. So based on that control logic, we can get in the maintain about the constant speed. So this cruise control is the longitudinal control function that regulate the vehicle speed. It is maintained about the constant speed. So we have to find the actual speed, then compare with the desired speed. If I want to maintain about this 80 kilometer per hour means we want to fix the desired speed is the 80 kilometer per hour. It is compared with that actual speed. From that comparison, it will generate the speed error. So based on the speed error, we have to given the throttle command used by the Kp into speed error. Kp representation for the proportional gain value. Then control speed is the actual speed plus vehicle gain and the throttle control. So this feedback later used in the AC's adaptive cruise control, AAB, adaptive emergency braking, and the ADAS system. We can extend for this logic also. Here we use in the simple P control for the UG level student. Suppose you want to go with advanced level means we can use for the different type of the controller and compare with the all the control. Actually, here used for the closed loop control, we fix the set speed, compare with that actual speed, and generate the speed error used by the P controller to control the system, and I have to control the throttle command. Then we maintain about the vehicle speed. Actually, it is work in the closed loop control. Suppose we can, given the closed loop control, continuously measure the actual speed. Control output should be limited the realistic throttle range. We put the weight millisecond record to the loop behavior like real-time controller. Actually, this is the front panel about the LabVIEW. So here is the controller and the indicator. Controller we got to use in the desired speed, actual speed, KP gain, vehicle gain, stop button. Then indicator, speed error, throttle command, control speed, and the speed versus time chart. In that LabVIEW, you can understand about the block diagram and the front panel. So that time we explain about the how to make it the block diagram and the front panel. So this is the general block diagram. So the speed here we have to compare with the desired speed and the actual speed. From that speed here we have to give the throttle command. So this is a step-by-step implementation. So we want to create the desired speed and the actual speed control. So place with the while loop. In that LabVIEW we have to put the while loop. It is because continuous running that we have to use in the while loop. Subtract the actual speed and from desired speed, multiple with the gain value. So we given the throttle command. Update the control speed using the vehicle gain. So connected control the speed gauge and the waveform chart. Run the VA and vary the desired speed. Tune the KP for the smooth response. Record the observation for three different gain. So this is a basic procedure for the how to develop in the LabVIEW platform. Here is the various parameter selection, the tuning. Here we are used for the desired speed from the 0 to 120 kilometer per hour. This is the definition for the reference vehicle speed. This is the KP value. The KP value is the vary from the 0.1 to 5. So this is the important for the tuning and achieve the fast response. Total limit we use in the 0 to 100 percentage. Waiting here use in the 100 millisecond. Then vehicle gain 0.01 to 0.1. So now it is the basic understanding. So there's a we want to tuning the KP value. Start with the small KP and increase the gradually. So too low KP gives a slow correction. So too high KP maybe create the oscillation. Use the chart to compare the response time and the overshoot. We want to, our aim is the stable and the smooth response based on the tuning. So this is expected. Suppose we are to give the desired speed 6 means its actual speed for 40 means you want to increase the speed. So there is a positive error. Throttle command is the increase. And similarly, the desired speed is the 60 and actual speed is 60 means it's a 0 error. So that you don't need to give the any throttle command. So it is maintained about the constant value. So desired speed 60 and actual is the 80 means a negative error. So you have to reduce the speed. The high KP is the fast response, but maybe the oscillation. This happen for the high KP value. So similarly, you want to troubleshoot. If you want to check that while loop everything is correctly, the millisecond we want to maintain the overload. If response is too aggressive, reduce the KP value. If speed never change, check the vehicle gain and wire direction. So if any of it is not connected means it is also we will not get the proper response. Use the saturation to avoid the unrealistic throttle value. So this after completion of this experiment, student can expect the feedback control vehicle speed system, build a basic P controller in the LabVIEW, tune the KP and observe the speed response, use a chart output interrupt the dynamic behavior. And so next learning terms is speed control experiment into the adaptive cruise control. So this is only the maintain the speed. We don't bother about the what is the vehicle in the next to our vehicle. So we are not bothered about what is the distance travel in from the next to vehicle. So that is this is the normal cruise control. The next experiment we discuss about the adaptive cruise control. Vehicle not only maintain the speed but also react to the distance from the leading vehicle. Okay, so this is a flow. We have to go with the LabVIEW and run and we go with the task. So this is the basic understanding. What is the observation from this LabVIEW experiment? For the first cruise control LabVIEW, we can get in the various KP values 0.5, 1, 2, and 4 and record the speed error and the total command. Identify which KP give the smoother response. Explain why the saturation is needed. Some of the basic Viva question. So what is the feedback control? Why is the actual speed subtract from the desired speed? What happened when KP is very high? Why is the weight used in the while? So this is all on the basic understanding question. Now cruise control developed by the LabVIEW platform. Now the start button, we go to the LabVIEW. In a LabVIEW, the LabVIEW is available in any LabVIEW. Student version is there. You can easily download and activate the student version. So now I create the blank PI. So you know about in the LabVIEW the two ends, the front panel and the block diagram. So whatever the front panel you see in the dashboard in your vehicle, it's like about this the front panel. Whatever we do in the controller in that block diagram. So we want to control T to maintain about the parallel one. Now I want to need it for the two measurement, desired speed and the actual speed. So I want to give the input. So whatever the input we can do in the front panel. We want to do in the any logic operation means we do in the block diagram. So in the front panel, right click the numeric. I want to need for the so two values. So desired speed and the actual speed. So I will make it any icon. So horizontal fill or there's a meter, any a norm, anything we can do it. So I put the horizontal representation. This one. Actually, this is I can mention the desired speed. So I want to give the how much value needed. So I want to vary from the desired speed from the 0 to 200 kilometer per hour. The scale I put the 0 to maximum 200. Okay, I want to display the value. So right click and digital display. I can see the how much value. Okay, vary the how much value this display in the digital speed. This is a decide speed. Same I want to need for the actual speed. I make it the copy, control copy and view. So this one is the actual speed. Now I think everyone we want to input in the while loop. So right click, I put in the while loop. So the section under the while loops, I want to create the while loop. Under the while loop only I put the desired speed and the actual speed. I want to, this is some logical operations. We compare with the desired speed and actual speed. So I want to need for the subtraction block. So the numeric and I put the subtraction. So subtraction is the desired speed is the first value. And actual speed is we put in the feedback. It is like about the negative feedback. So actually in the negative feedback we taken about the actual speed. So this is for your error value. Okay, this is the error value. So I want to display in the error. So speed error. I put the right click and the numeric. So I put the display also here. So numeric. Speed error. So speed error, how much speed? So 0 to 200 kilometer means how much speed error. So I put this speed error. So the display. So I want to vary the speed from error from the 0 to 200. It's not that much error. So I put this otherwise I put the 100. The display the error. So you want to in the digital display out also it is possible. Digital display. How much error? Okay, so speed error is there. So this we connected to the here. We want to check the how much speed error. The upper side is the speed error. Now this speed error want to multiply with the controller. So I put the numeric, then the multiply symbol, multiply. I want to keep it the multiply. The speed error multiply with the KP gain value. I want to vary the KP gain value. Numeric, then same horizontal file. Otherwise I copy and paste. Copy and paste. Actually, this is KP, proportional gain value. So proportional gain value should vary from the 0 to 5. I put the maximum as the 5 value. This proportional gain value multiply with the speed error. So this we can get in that error and the proportional gain value. So this is actually in the controller. Okay, the KP controller. That controller given to the throttle command. The throttle command vary from the 0 to 100%. So I put in the boolean. This is vary from the minimum to maximum value. That's comparison. And then in range and correct. Okay, and we have to put the range. This is the upper limit and the lower limit. So we connected to the here x into y. Then upper limit we put in the constant. Create constant. So I put in the upper limit is the 100%. And then this you have to click the here you have to move the cursor means you understand about this is the lower limit. Display the label in the lower limit. The right click and the create control. Sorry, this is not the speed error maintained. Then now it is the throttle command. So we given the minimum upper limit and the lower limit. Right click and create constant. Not put the create control. So here is up. You move the cursor means you can understand about the upper limit. So upper limit I put the 50% positive value. Then I put the lower limit create constant. Then minus 50%. Now I want to display the throttle error, throttle command, current command. So here I want to speed here, same speed here I want to connect it. Control V. So speed here 100 to 02. This is a throttle command. So command. So it is vary from the plus 50 to minus 50. Right click and we change the properties. This is the minimum values of minus 50, maximum values of plus 50. Okay, so minus and plus 50. This is a KP value. So I want to display this one. So I connected to the throttle command to this output to the throttle command. And I want to display the desired speed and the actual speed. So the same speed here I take and copy. Here you can see that this is a desired speed. How much I need desired speed. Desired speed. So the desired speed varies from the 0 to 200. Then same way I want to connect to the actual speed. Actual speed is also vary from the 0 to 200. Here you connected the desired speed is connected to the desired speed connect wire. Then actual speed connected to the actual speed wire. That is the total command. This is vary from the plus 50 to minus 50 total display. Now I want to stop this while loop. Sorry, here is a nearby. Right click, create control. Create control is stop the button. Now I want to maintain the waiting period. Right click timing. So waiting 100 millisecond. I put the right click constant. Here's the 100 millisecond waiting period. Seconds. I want to record the values. Record the desired speed. So I want to use the graph. The waveform graph. Waveform graph ready from the speed versus time. Time. Record the value. Record the value. Record the actual speed. So now it is not connected. So I want to record the value. You right click and indexing. I want to save the data. There's a indexing. Actually, this is your front panel and this is your block. So actually, in your vehicle, it's a front panel only available. So I put the stop button somewhere here. Okay, so this is your front panel. This is your display the dashboard in the desired speed. This one is the actual speed and the throttle command, how much command you want to give it, speed error. These all are in the desired actual and values, KP value. The KP value vary from the 0 to 5 value. Suppose we could take the table from the various KP value. So 1, 2, 3 simultaneously we taken and record the response. Based on the response, I find out the tuning fine value for the KP value. So generally how to tuning means there's a separate area. Now we ought to doing the trial and error method to find the KP value. Now I want to continuous running. This is a run continuously. This is for your run one time. So I put the continuously run. And now I put the actual speed you assume for the 120 kilometer hour. Okay, now this is the desired speed I want to need for the 100, maintain the 100 kilometer per hour. You see the display 100 kilometer, then actual speed is the 120. Now you need for the kp value, so very low value, so 0.5. Speed error is the minus 120. Actually, we want to put the speed error in the both positive and negative value. So 1 minute. Stop the button. So I change to the speed error. So speed error value from the properties. So because of the both values possible. So minus 52 plus 50. Minimum value is minus 52 plus 50. Then we can see in the positive error and the negative error. So this is your actually the negative error is minus 20 value. And now you have to put the kp value, means that the throttle command is the minus 10. Suppose I increase to the 1. 1 means the throttle command is a minus 20. Suppose I increase to the 2. 2 means the throttle command is a minus 40. Suppose it's a very high value, means you can get in the fast response, but some disturbance is there. Suppose we go with that, so slow response means the less value, less kp value means we can get the response, but it is a smooth response. Yeah. So you see in the 100, 120 means I want to give the command is the minus 120. Suppose I want my actual speed is the 90, 80. 80 means it is in the positive error. You want to increase the total command. So 10, you want to give the command to the 10 value. So this we have to press the stop button, so you can maintain the record the value. So we put the randomly 100 and 120. So initially it is maintained about the 120 kilometer speed. Then after some time period, I change to the actual speed is the 80. So it is go with the down. So 80 means I want to increase the total command. Suppose 120 means I want to decrease the total command. This is the basic understanding about how this cruise control is working. So actually cruise control is working about the based on your desired speed. If I want to maintain 100 kilometer per hour means, so we can get in the based on the positive or negative error. I give the command to the throttle command. So to increase the throttle or decrease the throttle. Yeah, this is only done in a practical manner. So throttle command you want to put in some controller to increase the command or decrease the command and maintain about the constant speed. I'm maintain about 100 speed. That is the basic explanation about the cruise control. Next video we discuss about the adaptive cruise control. So thank you.